Good afternoon, everyone. Thank you for joining us today. I hope that you have been having a good week so far. I know we're in the middle of the week already, and school has started, and there's so many challenges that everyone is dealing with about safety. Just want you to know that we're here, a reliable resource for you all, parents and students. If you're a parent who's looking for extra help for your students, here's an opportunity. And if you're also a student that needs some help with your homework, here's also an opportunity. This is a free session, and today's topic is going to be on exponents. And if you're interested in getting this through Zoom, also let us know. We'll be able to get you connected to the Zoom session directly so that you can ask the instructor questions directly. Otherwise, you can join us on Facebook and on YouTube. While you're on our Facebook account, please give us a like and a follow. And if you're on YouTube with us, please subscribe to the channel and also like this video so that we can. So when you subscribe, you will be notified whenever we go live again. And I want to also remind you that if you're a student or a parent that wants something more private for your students, we're also offering that. And there's going to be an instant discount if you sign up when this session is going on. If you sign up, we'll be able to give you a discount. We're going to offer topics such as we're going to offer subjects like math, English, science. We also help you with the test prep like SAT, ACT, and your PSATs. And we're going to offer this as private one-on-one sessions, or we can also have semi-private, which for us is just 2 students or 3 students learning together and learning the same things. Or we can also have a small group. We don't really do large groups per se. So we're going to do a small group for our students. So that's usually about 4 students. So we like to keep it about 8 students for our smaller groups. So if you're interested in that, go to our website, mathis.com. You can also send us an email at info@mathis.com. And feel free to give us a call as well if you're interested in this. But this, right now from 3:30 to 4:30, our tutors are going to be working on exponents, and we'll be looking at a lot on multiplication and division of exponents, and they may actually get into some algebra before the session is over. So please hang tight and ask questions. There will be someone checking YouTube and Facebook to make sure that all your comments are addressed. But if you want to be able to speak with or contact the tutor or the instructor directly, let us know. We can give you the Zoom account for you to join directly. So thank you, and we look forward to your learning and also your success in this semester. We want to be here to help you as we all navigate the COVID situation and school and virtual learning. We have children that are going through the virtual learning. We understand the challenges. So we're here to also use some of what we have learned and what we have gained from how we've adjusted to the new method of learning for the students. We can also help you navigate that as well. So if you have any questions, feel free to let us know. We'll be glad to answer any questions, because our goal is to help 5,000 students become better at math or exceed their expectations in math, and also to make sure that students are successful all around in what they do. So give me a second, and I'll connect you directly to the Zoom session right now.
There we go.
We got one answer.
We got one, so you're on the right track, but you're a little high there. What we're doing, you probably did the right method, but you might have done the multiplication a little bit too much. We have 3 caret 3. What this means is we're going to be taking 3 and multiplying itself by itself 3 times. So 3 caret 3 is 3 times 3 times 3, which equals 27. So it looks like we got answers kind of on either side of that. We got both 81 and 9. So 81 would actually be 3 to the 4th. I'll show you how that works. 3 caret 4 is going to be 3 multiplied by itself 4 times, which gives us 81, which is one answer I saw. And I also saw 9 as another answer. That would be the same as 3 squared. I keep making this 8. So 3 squared would be 3 times 3, which equals 9. So y'all are on similar tracks, but what you want to do is you only multiply the number by itself however many times this exponent tells you. So we'll give another example a shot here. We're going to do 9 to the 2. So I'm going to see if I can figure out how to scroll down here. If I can't, I'll just, there we go. I'm going to let y'all try another example. We're going to do 9 squared. Let's see if y'all can work that one out for me. And I'll probably go ahead and give y'all another example after this one too, so we can make sure that if there's anything that I explain at any time that isn't clear, or I'm ever going too fast throughout the duration of the lesson, feel free to speak up or send a message and let me know. Oh, we have an answer. We have 81. That is correct. 81. Y'all are both right. 9 times 9 is 81. Exactly right. Just following your multiplication tables. I'm going to give y'all one more. Let's do, I like this one. Let's do 5 to the 3rd. So we got 5 as our base number and 3 is our exponent. I'm going to give y'all a chance to work out 5 to the 3rd and shoot me what the answer is in the chat whenever you get there. All right, 125 and 125, exactly. 5 times 5 times 5, 125. So I think y'all got that down. So I want to tell y'all something else with bigger numbers. Sometimes you can break those down by factoring, and you can rewrite them as exponents. So I'm just going to kind of show this to y'all to further illustrate the concept and show y'all some other ways that exponents might be used or might be written. So as an example here, I have 56. I just picked a number, and what we're going to do is we're going to work out the prime factorization of 56. So all that means finding the prime factorization is just breaking down the number over and over and over until we have the smallest numbers, or the prime numbers, that can multiply together to give you that big number that we're starting with. So we have a little factor tree as an example here, and I think y'all have covered this before. If the concept's unfamiliar to anybody, please feel free and you can stop me or slow me down, but I think y'all have done this before. So we're going to do the prime factorization of 56. We would just break that down so that we have 2 and 28. 2 multiplied by 28 is 56, so that's the same thing. 2 is a prime number. That's as small as it's going to go. So we're going to break down 28 into 2 and 14. And then we'll break down 14 into 2 and 7. So essentially what we were able to do is we were able to take 56 and rewrite it as 2 times 2 times 2 times 7. So one thing that you might notice is it's really cumbersome and kind of a pain to write out 2 times 2 times 2 over and over again. And you can imagine with any really large numbers, that could just become more and more cumbersome. So what we can do is we can just simplify this with exponential notation. We know from what I told y'all before that an exponent is just a number multiplied by itself. So we can group these 3 2's and rewrite them as 2 to the third. So 56 is simply 2 to the third times 7. So moving on, I'm going to zoom in here a little bit for you guys so you can see it more clearly. Here we go. So now that we understand kind of what exponents are and why we might use them, we're going to look at some mathematical operations that we can do with exponents. So one common thing that you're going to be doing is you're going to be multiplying and dividing exponents. So whenever we're multiplying or dividing similar numbers with different exponents, it's a fairly simple process. When you multiply 2 numbers raised by different exponents together, you add the values of the exponent, and whenever you divide 2 different numbers with exponents, you subtract the exponent values. So I'm going to show you all what this means. A couple examples here. We'll look at 2 squared times 2 to the fourth. So since we have the same number here, just raised to different powers, what we can do is we can simplify this. Whenever you multiply these together, it's actually the same thing as saying 2 squared times 2 to the fourth is equal to 2 raised to 2 plus 4. 2 being the power that we had on this first 2 over here, and 4 being the exponent that we had on the second 2. So we can rewrite 2 to the second times 2 to the fourth as 2 to the sixth. Sixth coming from the sum of the exponents of the 2 separate numbers. The inverse holds true whenever we divide numbers raised by various exponents to each other. So for instance, if we look at 3 to the 7th divided by 3 to the 4th, we can simplify that by saying this is the same as taking 3 to the 7 minus 4, which is equal to 3 cubed, which, by the way, is 27. So give me just a second here. I just got a YouTube link. I'm going to open that up and see it. But 300 million viewers. Oh my goodness. That's not true. I just made that up.
Oh my god, no.
I wish that was 300 million.
Yeah, 300 million. You're going to need to give me another 2 or 3 weeks. Yeah, I'm going to need another 2 or 3 weeks until
We need to build our following.
Yeah. All right. So mine is loading and the screen looks good. I don't see any kind of a chat, but I'm going to turn off that audio because I heard myself echoing when I opened it up. Let me move on here and keep on with the lesson. We'll keep an eye out for people joining the YouTube video. Anyway, I was in the example of walking y'all through dividing exponents. So we learned on the previous slide that whenever you divide exponents, you just have to subtract the exponents from each other. So 3 to the 7th divided by 3 to the 4th is 3 to the 7 minus 4, 3 cubed, 27. Notice that's a lot easier than taking 3, multiplying itself by 7 times to get some huge number, then multiplying itself by 4 times to get some huge number, and dividing them into each other. All right. Now I have some examples for you guys to try. So y'all don't have to get the final answer and work out all of the gross math that might come to these. I just want to know, it's like for this first problem, I want to know 5 to what power. So the answer I'm looking for is if you have 5 to the 7th times 5 to the 8th, that's going to equal 5 to what power? And I will open up the floor to you guys. So if anyone on YouTube or in the Zoom is able to get the answer, let me know and shoot it to us in the chat, and we'll take a look together. So 5 to the 7th times 5 to the 8th is equal to 5 to the what? I think Jaden's working on it. Here's my chat.
Yep, we got 5 to the 15th for number 1.
Nailed it. That's exactly right. So yeah, you did it right. I'll show Jaden how we got this. So what we did is we just said, since these are the same base numbers, a couple different exponents multiplied by each other, we can add those up. So 5 to the 7th times 5 to the 8th is the same as 5 to the 7th plus 8, which is equal to 5 to the 15th. Exactly right. So I'm going to scroll down here and let y'all take a stab at this next example. 7 to the 15th divided by 7 to the 13th. What is that answer going to be? So
We got one answer.
got an answer? Yep.
7 to the 2nd power.
7 to the 2nd power. That's exactly right. And we got that by subtracting 13 from 15. So again, you can probably imagine that just subtracting these two exponents from each other is a lot easier than taking 7, multiplying by itself 15 times and getting 1 billion or whatever, and then 7 to the 13th, and it's a lot of painful mathematics. But this, we just get 7 squared, 49, and we're all done. Very good. So we're going to talk about square roots now and how we can actually write those as exponents as well. It's coming up on 4 o'clock, but I think I can get through this slide before I open up the floor. So square roots can be written as exponents. And what you're about to see is that a square root, or taking the root of a number, is the dead opposite of taking the exponent of a number. So whenever you're writing a square root as an exponent, y'all might have seen this symbol before. So this is a square root symbol, and x is just a placeholder for a number, any number that you want it to be. And we can actually rewrite this square root as x to the 1/2. So what the square root is it is the reverse of squaring a number. So if squaring a number is multiplying it by itself, square rooting a number is looking at a number, taking a step back and saying what number times itself is equal to this number. So a simple example, we take a look at square root of 4. What we want to do is we want to say what number times itself is equal to 4. We know that that's 2. 2 times 2 is 4. So the square root of 4 is 2. The cubed root would be similar. So the cubed root means the third root. If you see this square root symbol, and you'll see a small number written to the upper left, that is the exact opposite of the exponent. So like if I were to say 2 to the third is 2 multiplied by itself 3 times. Third root of a number is me asking you what number multiplied by itself 3 times is equal to the number under this sign. So the cubed root of 8 is going to be the third root of, if we factor this out, it's 2 times 2 times 2. So bingo, there's our answer. Since 2 multiplied by itself 3 times is 8, then the third root of 8 is 2. And fun fact, by the way, the same way that we were able to write the square root as an exponent, we can do the same thing here. So the third root of 8 is the same thing as saying 8 to the 1/3. Similarly, we can go forever, 5th root, 6th root, 7th root, but I'll just show y'all like the 4th root is finding out what number multiplied by itself 4 times equals whatever number you have under the symbol. So if you're looking at like 4th root of 16, that's the same thing as 4th root of 2 times 2 times 2 times 2. Look at that, we multiply 2 by itself 4 times, we get 16. So the 4th root of 16 is 2. And similarly, taking the 4th root of a number can be written as an exponent. (16 to the 1/4) would be the same thing as saying the 4th root of 16. This is all just different notation for saying pretty much the same thing. All right, so before I move on to some examples illustrating this concept, I believe it is just about 4 o'clock. I'm not sure how many, if any, we have following us on the YouTube channel, and if we have any kind of a live stream chat. But for those of y'all on YouTube or in Zoom, I wanted to open up the floor real quick. I think a lot of y'all are already back in school. If there have been any concepts, not even related to this, what I'm talking about, but anything in school that you've gone over recently that is confusing or you would like some extra help on? I'm sorry, what was that?
Oh no, you didn't mute it. Or any homework problems you might need help solving, getting through.
Yeah, she said it better than I did. If y'all have any tricky homework, any tricky concepts, anything that y'all want to look at that I'm not covering in this lesson, feel free to let me know and we can take a break from exponents.
Literal equations?
Literal equations. I have no idea what literal equations are. Could you show me an example or type up an example of what you're looking for? I'm going to Google that in the meantime. I'm sure I've done it, but I know that they tend to change the terminology that they use for things over time since I was in school. So what is a literal equation?
You mean linear? Possibly? No, literal.
There is a such thing as a literal equation. It's an equation that contains more than one distinct variable.
Oh, okay.
Count. So literal equations are simultaneously solving equations with 2 different variables.
I didn't know that's what they were called these days.
Yeah, neither did I. So that would be a bit of a digression, but we can certainly address that. And for those of y'all watching on YouTube, we're taking a quick break from our originally intended topic of exponents because we had a question come in about literal equations. Questions are good. If y'all have any, feel free to cut me off and stop me. So what I'm going to do is I am first going to talk about what a literal equation is and what your required criteria are to solve a literal equation. So first of all, a literal equation is one with more than one variable. So an example of that would be x plus y equals 5. This would be, Anastasia can tell me if I'm correct, this would satisfy the definition of a literal equation, what you're looking at, right? Because it has 2 variables. So these variables, x and y, are placeholders for basically any number. So we can solve literal equations the way that we solve normal equations, but there's one trick. With literal equations, you need to have the same number of equations as variables in order to solve it. So I saw that, Jaden. What's up? So why we need the same number of equations as variables? With this, we could have unlimited answers pretty much. So as an example, I could say x equals 4 and y equals 1. Or I could say x equals 3, y equals 2. I could say x equals 100 and y equals 95. I can literally make up an infinite amount of combinations of variables to solve the equation that we have right here. And the reason that is because we don't have enough equations available to us. We need to have 2 equations in order to solve a literal equation. So, am I on the right track, Anastasia? Am I answering your question? Is this what you were curious about? Let me know in the chat. And what I'm going to do is I'm going to come up with an example of a literal equation that we can solve, and I'm going to show you a couple ways to do it. So for those on YouTube stream that are just tuning in, so we're supposed to solve for one exact variable.
Yeah. Okay.
So I think that's what I am getting to. I think you're talking about what's called the substitution method.
Yeah.
And I'm going to show you how to do that. So we're going to solve a literal equation. We're going to need 2 equations with x and y. So I'm going to say x plus y equals 5. That was the same as the example equation I gave you. And then I'm going to say 2x minus y equals 2. And hopefully these numbers don't turn ugly on me. I don't know if they will yet, but we'll see. So how do we solve 2 different equations at the same time? So what we can do is we can first look at this first equation, and we want to get the variables to 2 different sides. So first, what I'm going to do is I'm going to subtract y from both sides, and we're going to find out that x equals 5 minus y. So all we did is we took that first equation and we rewrote it in terms of x. We could have done the same thing with y. We could have said y equals 5 minus x. So now we know what x is. So we can take that x value and we can plug it into the second equation that we have over here. So since x equals 5 minus y, this turns into 2 times 5 minus y, and then minus y equals 2. So we multiply this 2 out, we get 10 minus 2y minus y, which is 10 minus 3y is equal to 2. Minus 3y equals minus 8. I did that by subtracting 10 from both sides. And then we can solve for y, and we see that y is equal to 8/3. So in our set of literal equations, we solve for the second variable, y. So how do we solve for x? Now that we know what y is, all we have to do is take it up to our either of these two example equations, plug in our y value, and then we can solve for x. So we'll go to the first one since it's easier. Since y equals 8/3, we see x plus 8/3 equals 5. We subtract 8/3 from both sides. 5, in terms of thirds, that's the same as 15/3. So 15 minus 8/3 is the same as 7/3. So whenever I solve these two equations simultaneously, I got that x is equal to 7/3, y is equal to 8/3. And let's make sure, I really hope I'm correct. We're going to plug these two numbers into the second equation to make sure that I did this right. So for our second equation, just to do a sanity check, 2 times x, which is 7/3, minus y, which is 8/3, should equal 2. So we get 14/3 minus 8/3 is equal to 2, or 6/3 is equal to 2. And what do you have it? 2 equals 2. So we did do that correctly. So did that answer your question? Is that what you were looking for, where we have like two distinct equations with two variables, and you simplify and plug one into the other? Did that example make sense? And is that what you were asking for?
Good.
Awesome.
Yeah.
All right. You put me on the spot, but that's good.
No, that was good.
That's good. Excellent. All right. So for those who are watching on YouTube, went through that pretty quick because that was just a question that came up. Hopefully, it was helpful to anyone watching. If anyone has questions about what I just did or has any other topics that they want me to cover throughout the lesson, feel free to stop me and let me know. But for the time being, I'm going to go back to my originally planned topic, which is exponents. I'm going to do a very, very fast recap of what we've done so far, because I think we had a few new people come in on the YouTube live stream. I'm talking about exponents today. An exponent, also called a power, is just a way of saying a number multiplied by itself however many times. So the example I gave, 2 to the third, 3 is the exponent. What 2 to the third means is 2 times 2 times 2. 2 multiplied by itself 3 times. Next, what I covered is that we can do some basic mathematical operations with exponents. Whenever you multiply exponents together, you add the exponent values together. And whenever you divide exponents, you subtract the exponent values from each other. So we went through a few examples of what that means. 2 squared times 2 to the fourth was our first example. I just mentioned that whenever you multiply exponents together, that means that you add the exponents. So 2 squared times 2 to the fourth is same as 2 to the 2 plus 4, which is the same as 2 to the sixth. Conversely, whenever we divide exponents, we subtract the exponents from each other. So we have 3 to the seventh divided by 3 to the fourth as our next example. This is the same as 3 to the 7 minus 4, which is 3 to the 3. So again, this is just a quick recap. Sorry if this is a little fast for anyone that is just now joining, but hopefully you catch up throughout the duration of the lesson. And if you have any questions, step in and let me know. The last thing that we've been covering was that square roots, or rooting a number to any power, is the exact opposite of an exponent. So if an exponent is multiplying a number by itself, taking the root of a number is looking at a number and finding out what number multiplied by itself is equal to said number that you look at that. So an example illustrates that more clearly than I can kind of explain it. Like let's say we take the cubed root of a number. We looked at a cubed root of 8 in an example earlier. So what we're asking is what number times itself 3 times, 3 based on this number that we have right here in the upper left of this root symbol. What number times itself 3 times is equal to the number under the symbol? We know that the third root, 8, is equal to 2 times 2 times 2. 2 times itself 3 times is equal to 8. So the third root of 8 is 2. All right. So after that quick recap, I have a few examples for you guys to try. And if anyone on the YouTube chat or anyone in the Zoom chat wants to step in and answer the question at any time, feel free to do so. So this first example, I want to know what is 2 to the third divided by the square root of 2. So all I'm looking for here is the answer is 2 to some power. And I want to know what that power is. So 2 to the third divided by the square root of 2. I've been talking a lot, so I'm going to open up the floor to you guys and give y'all a shot at figuring this out. And if anyone has any answers, feel free to shoot them my way. If anyone has any questions, wants me to go back and slow down, feel free to shoot that my way as well. All right, go for it. All right, does anyone have any ideas? Is there, let me see, we might have lost a few people, but I'm going to give y'all just a little bit longer. And if not, I'll walk y'all through how to solve this example. So I'm going to go ahead and make myself some room here. All right. So some of y'all may have solved this, but I'm going to go ahead and take y'all through how to do this regardless. So we have 2 to the third divided by the square root of 2 equals question mark. So we're kind of combining two concepts that we've covered in this lesson so far. So the first is whenever you're dividing exponents by each other, you subtract them from each other. And the second is whenever you're taking the square root of a number, that can be rewritten as an exponent, saying 2 to the 1/2 rather than the square root of 2. So I'm going to rewrite this. We see 2 to the third divided by 2 to the 1/2. This is going to be equal to 2 to the 3 minus 1/2. Your answer is going to be 2 to the 5/2. Is how you would solve this. The next example is similar, so I'm going to go ahead and solve that for you guys. Now we are multiplying and dividing exponents all in one. So whenever you multiply exponents, you add them up. Whenever you divide exponents, you subtract them. And we also know that the square root of a number is the same thing as saying the number to the 1/2 power, since it's the opposite. of squaring a number. So we could rewrite this as 7 to the 2 plus the 3 in the second term minus our 1/2 that we have in the third term. And this works out to 7 to the 4.5 or 4.5 or 9/2, however you're the most comfortable writing out and doing that arithmetic. So I have another example for you guys. It's similar to what we did before. There's one small caveat with this second number. I want to see if y'all are able to get it. So I'm going to give you guys a shot at solving this. If anyone has any answers, please respond in the YouTube chat or in the Zoom chat. If I don't hear anything soon, I will solve the problem myself and walk y'all through how to do it and hopefully alleviate any confusion. So what I'm looking for here is the answer I want, 7. This is going to be 7 to some power. And that was a very bad circle, so I'm going to try it again. So I want to know 7 to some power. 7 to what power is going to be equal to 7 to the 4th divided by 4th root of 7. So feel free to take a stab at it. And if anyone has any answers, shoot them to us in the chat. I'll give y'all just a minute to give that a try. Alrighty, I'm going to go ahead and walk you guys through how to solve this one. So what we have is 7 to the 4th divided by 4th root of 7. So what on earth do we do here? The first thing that we need to know is that whenever we're dividing exponents by each other, all we have to do is we subtract the exponents. The second thing we have to do here is we have to figure out what exponent is this. So we saw on a previous slide that 7, the 4th root of 7, can be rewritten as 7 to the 1 over 4. That's the same way of saying it. You can just rewrite it as an exponent. So what we do is we take 7 to the 4. We subtract 7 to the 1 over 4. And we get 7 to the 15 over 4. Or 3 3/4, or 3.75 as a decimal, however you're the most comfortable writing it out. All right. So what if we square a square? We can do that. So if 2 squared is 4, we can also do 4 squared is 16. I have over here, if you are squaring a number that is itself already a square, you can simplify by pulling out the exponent. So what do I mean by that? We're looking at 4 squared. We know that 4 is the same thing as 2 squared. 2 multiplied by itself. So we can simplify 4 squared as 2 squared squared. And then what we would do in this instance is we would actually multiply the exponents by each other. So this would be the same thing as 2 to the 2 times 2, which is equal to 2 to the 4th. So all we're pretty much saying here is 16 is equal to 4 multiplied by itself, or 2 multiplied by itself 4 times. So we know that 2 squared is 4, so 2 multiplied by itself twice. So if we square 2 multiplied by itself, that works out to 2 times 2 times 2 times 2, 2 to the 4th. I had an example over here. So the converse is true. You can also square numbers that are under square roots. Let me get my drawing tool. So we want to solve third root of 7 cubed, or the cubed root of 7 cubed. So we actually know that taking the third root of a number and taking a number to the power of 3 are opposites. So what this simplifies out to be is it is 7 to the 1/3 to the 3, which would equal 7 to the 1/3 times 3, which equals 7. All right, so I'm going to open up the floor to you guys to try a couple to kind of illustrate the concept of squaring squares or cubes, or taking a number raised to an exponent by another exponent. So the first example, we're going to be looking at 7 to the 5th squared equals what? So what I'm looking for is 7 to what power? What does this end up working out to be? So I'll give those of you on YouTube and those of you on Zoom just a minute to take a shot at this. And if anyone has an answer, feel free to chime in and let me know. Or if anyone has any questions, I mean, if I don't hear anything here in a little bit, I will work through the problem and show you guys how we would solve this. So the floor is open to y'all. Alrighty, some of y'all that are watching on YouTube may have solved this, but the chat function might be a little funky to work through, but that's okay. I'm going to show everyone how to solve this in case anyone had any questions or wasn't able to get it. So what is 7 to the 5th squared? 7 to the 5th squared. Since we are squaring a number that's already raised to an exponent, we just end up multiplying these two exponents by each other. So this would be 7 to the 5th times 2. Our answer would be 7 to the 10th power. So 7 to the 5th power squared would be 7 to the 10th power. I'll go ahead and work through this next example. What is 3 to the 3rd power, all raised to the 4th power? Similarly, we would just end up multiplying these exponents by each other to get our final answer. So this would be equal to 3 to the 3 times 4, which is equal to 3 to the 12. So as one last example that I had planned for this lesson, I wanted to kind of throw together a hodgepodge of numbers that you have to use all of the concepts that we've gone through to figure out. I've actually solved this one out for you guys, so I'm just going to walk through how we would do this, and if anyone has any questions, please stop me and let me know what the heck, or whatever's going on. So we are looking at 4th root of 2 times 2 to the 1/3 times 2 cubed times 4 squared. Oh, what on earth is our final answer? So what we want to do is we first want to simplify this so that everything is in terms of 2 raised to some power. So we know that the 4th root of 2, we can write that as an exponent. 2 to the 1/4. It's synonymous with saying the 4th root of 2. We multiply that by 2 to the 1/3, which is already worked out for us. Multiplied by 2 to the 3. And then what do we do with this 4 squared? Well, we know that 4 itself is a square. So 4 is 2 squared. So this last term would be 2 squared squared, which we saw in the previous slides would be 2 to the 2nd power times 2, which is 4. So once we have all of these written in consistent exponential notation, we can multiply all the numbers by each other. So we get 2. We add up all of the exponents whenever we multiply these numbers against each other. So our answer would be 2 to the 1/4 plus 1/3 plus 3 plus 4, leading to our final answer of 2 to the 7 7/12 power. Make sure I did that right here. 1/4 plus 1/3 is the same as 3/12 plus 4/12, which is 7/12. So yeah, that's right. As a last note, we discussed literal equations a little bit earlier. Exponents can pop up in algebraic expressions too, and they could very well pop up in some literal equations that you're solving later. So these can often come up in algebraic expressions. If we're looking at variables instead of numbers, don't get scared because we're able to solve it the exact same way. So x is just some number. If we were to solve x cubed times the square root of x, what we would do is we would just add the exponents the same way as we did before. So this would be x to the 3.5. Similarly, if we were to divide exponents using some variable, we would still just subtract the exponent values from each other. So x to the 4th divided by x to the 3rd is equal to x. So with that, that kind of concludes everything that I had planned for today. I wanted to show you guys what exponents are and some common mathematical operations that we might have to do with exponents. And courtesy of a question, we had a bonus. We got to look at some literal equations and what those are and how to solve them using what I call the substitution method back whenever I was in school. Y'all might call it something different now, but I call the method that I used the substitution method. So with that, for those on YouTube or in Zoom, if there are any questions, please send them our way. And also, if anyone has any ideas for topics that you might want us to cover in future sessions, things that you're going over that are maybe a little bit confusing, or things that you just want to know more about in general because you're curious, feel free to either message us in the YouTube chat or in the Zoom chat, and we can take a look at that and we can plan some future sessions to go over those concepts for you guys. So opening up the floor one last time to questions and suggestions, because I believe that we're at the end of our scheduled time, but I'll give y'all just a few minutes if anyone has anything that they want to add here at the end. Alrighty, we have a suggestion. We've got relations and functions, discrete and continuous functions, that's right, for Algebra 2.
Oh, that's not us, but we'll pass that along to the high school students.
Yeah, is Algebra 2 in middle school? I don't remember. We could cover it, but I don't remember if I...
No, we could.
I don't remember if what grade are you in? If you don't mind me asking. Because if y'all are covering it earlier, then it's certainly something that we can cover in our 7th and 8th grade sessions. I'm not sure what y'all learn right now and when. That's a good topic, and we could cover it. Okay, you're in the high school section. All right, so that makes sense. So we have a different time that is scheduled for high school students that's geared towards more high school level problems. I am going to find out what that time is real quick. Unless you happen to remember offhand, Eliza, I'm going to have to look it up.
I believe it's tomorrow. Thursdays from 3:30 to 5:30 is algebra and geometry.
Gotcha. All right, so that's a good question, and that's a topic that we're definitely going to pass along. So for you at your level, for the high school sessions, you'll probably want to attend these online tutoring sessions that occur on Thursdays at 3:30 to 5:30. Wednesday, the one that we did today, was intended for more of the 7th and the 8th grade level. So it's probably stuff that you've already covered. So Thursday sessions for algebra and geometry, the same time, 3:30, they last a little bit longer, 3:30 to 5:30 might be a better fit for you and for your question. But we will pass that topic along, and hopefully they cover it soon. Otherwise, does anyone else have any additional ideas for topics that they would want us to cover, or any last minute questions? Perfect. They said that they're going to address the question tomorrow, so that'll get passed on. All right, if no one has anything else, thank you very much for attending our session today. I know that some people kind of trickled in at different times, and it might have been a little bit tricky if you came in halfway through the session. But hopefully everybody was, excuse me, able to get something out of today and learn something. And otherwise, Eliza will be seeing you guys next week. I am not here next week, but she'll be teaching y'all. So I will not be here next week, but then I'll be here after that.
Cool. Bye, guys.
All right, bye. Thank y'all very much.